Hi everyone, we're going to do a quick chat about turning tools, um, i.e. the tools which are used on a lathe for turning. Um, there's a few different tools. We're going to talk about how they're made, how they're constructed, how they're mounted, and what they're used for. So the first thing is a knifing tool. Knifing tool. Um, Originally these are sort of high-speed steel, look something like this, and they're ground to a point. There's various angles on here the technicians will grind up. And if this is your component you're turning, you can use this to face off across the front, turn along the diameter. So that's a sort of year older style knifing tool. What we also have is tipped tools. Tipped tools are extremely versatile. Let's move that out of the way. This is a tipped tool, and this is the tool tip here. It's a carbide insert. The advantage of these inserts, you can see this one's actually damaged. The advantage of these, because there are 3 points and 2 sides, you can break this 6 times before you have to throw it away. So it simply sits on there, and then with an Allen key, it's tightened into place, like so. And it can now be used, again, for facing, for turning the diameter. Yeah, carbide tip, so it's quite strong. When you mount it in the machine, you're going to need to use a tool holder. I'll write that down. Tool holder. And this is what they look like. This is the tool holders we have in the workshop. And simply, the tool sits in like so. You want to have it as far back as possible for minimum vibration. And then tighten down to lock it in. There's a key that you use to nip these up. And then you have your adjuster screw on the top here. So that is how you set the height with the tip of your tool relative to the center axis of your component. So it's a knifing tool, and that's the tool holder. Next one, we've got a little tipped chamfering tool. It's quite well used, this. Chamfering tool. You can see the tip. Again, it's carbide, and the high-speed steel part is just being ground away to allow clearance. These are great for if you need, a corner taken off. I.e., you don't want a sharp 90-degree end. You can just touch up the side with that, and that'll take your corner off. If you need to go to a certain angle, then clearly that's less useful, and you have to make use of the compound slide, details of which are in other turning videos. Next, we have a boring bar. That's a boring bar. I'll write that down. Boring bar. Again, carbide insert, double-sided this time, so you can break it twice before you have to throw it away. And yeah, they're used for going down the bore. Can you see that? Yeah, down the bore, like so. and opening up holes to an accurate size, more accurate than drilling, and also will give you a better finish. And the last turning tool we're going to talk about is a parting off tool. They look a little bit like this. Parting off. And so, again, it's tipped. These tips just pop out with a screwdriver. It sits on this bar, and then it's held within a holder, which itself goes inside the tool holder. You can see the marks on it from where it's been gripped. There. So yeah, using your parting off tool, if you've machined your size here, clearly there's a bit still held in the vise. So you need to take your component off of your stock bar. You need to accurately measure how far down you're going. And then the process is just move the tool in and push through the component. Simply. As simple as that. A couple of things to know: if your radius is larger than how far this sticks out, and clearly you're going to need to extend it. But the more it's extended, the more likely it is that you'll end up with deflection. So, important that it's extended as little as possible. Single point tips. So these will need replaced every time you break them, and that's to be considered also. In terms of setting your heights, say that's my component. This is my tool. It needs to be in line with the center of your component. If it's too high, you're not going to do any cutting. You're just going to push against the component. And if it's too low, you're going to create too much heat for a start, therefore introduce heat to the tip, which will break. You're going to lose finish quality. Also, it's going to make the component want to ride over the bar. So just on the center, there's a tool setting video, just to explain it, just on the center there is where you want it to be. That gives the optimum cut efficiency. Okay, so that's pretty much it for the basic turning tools. There are more available, clearly, but these are the 3 or 4 most common ones we're going to use here. And that's all for then. So thank you so much.